Alright, room 20. Let's get involved in a transformation called enlargement. Really excited to get onto this. Lots of activities this week, so it's important that you understand it. Enlargement is a transformation of a shape to a bigger or smaller version of the shape originally. So you can see here I've got myself a square, and as you would assume, a square has the same width as it does height. The width is 2 centimeters and the height is 2. Now that's not to scale, but when you're thinking about the squares in your maths books, they are 1 centimeter squared. So it looks like there you've got a 2 centimeters squared, and I'll just put a nice cm just to remind us there as well. When it comes to enlargement, the key word is scale factor. Now, depending on what a scale factor is for your enlargement means how big or small your shape will enlarge by. So for this one, let me get a question going on, and would love to enlarge this shape by scale factor. I'm going to put SF for scale factor 2. Okay, so enlarge this shape by scale factor 2. Now, when I see the number 2 and scale factor, it means that every dimension of the shape becomes twice as big. So at the moment, I can see that my current square is 2 centimeters by 2 centimeters. So when I enlarge it, I need to make sure that this 2 centimeters becomes 4 centimeters, because that's times by 2. And this side becomes 4 centimeters, because that's times by 2. So I'm going to enlarge this shape by scale factor 2, SF2, scale factor 2, meaning that every side of this square will be 4 centimeters. So there's my 4 there and 4 there. Obviously just touch that up a little bit to make sure it's absolutely perfectly on the lines. And when you do the drawings here, you'll be able to do it. You can see there, absolutely spot on. The enlargement is now scale factor 2. Alrighty, let's edit this just for a second and ask the question, can we enlarge this by scale factor 3? And again, we're thinking about what scale factor 3 means for our dimensions. We're trying to look at the dimensions 2 by 2. So when I enlarge this shape by scale factor 3, it's going to be 3 times 2 for the length or the width, and 3 times 2 for the height. So again, when you're thinking about enlarging, I'm going to do 2 multiplied by 3, which gives me 6. 1, 2, 3, 4, 5, 6. And across by 6, that's 4, that's 6. And all of a sudden, when we touch that up just a little bit, this is my scale factor 3. Scale factor 3, because I'm timesing every dimension by 3. And of course, a square will have the same height as it does on this side and this side, so it means that all of these sides will be 6 because I've enlarged it by scale factor 3. Alrighty, this time around I've got another shape, and we're going to go back to our 2 scale factor enlargement. This time, of course, it's an arrow. Delightful. So we're going to try and enlarge this arrow by scale factor 2, and this time we're having to think about the dimensions a little bit more in depth. So I can see there that the top of the arrow is 1 centimeter. So let's make sure that's written in there. So that's 1. And down the side there, this is going to be 4 centimeters. Now across here, it's a little bit trickier, but look, it spans the 3 centimeter square. Now it doesn't look exactly the same as right across them, but I can see there it does span the length of 3, so therefore 3 centimeters. And because this is a symmetrical arrow, each of the other components are going to be equal. So over this side, that'll be 3 centimeters, and this length will be 4. All right, so scale factor 2, once again, means that we're timesing all dimensions by 2, which means that this 1 becomes a 2, this 4 becomes an 8, and this 3 becomes a 6. So let's have a go and see what my arrow can do this time. Alrighty, so let's just start off with a nice, easy breezy arrow. Great work. And let's zoom it in a little bit now and see whether or not I could span it across 2 at the top. And then when you're thinking about 2 at the top, we're also hoping that 8 going down that long length. Oh, goodness, it's tricky in this app, but essentially you get the gist. Hopefully understand that this is a bit tricky, but hopefully be okay. Okay, and we're just having a look at that length. So at the moment, it does absolutely span 2, because we're timing this by 2, 1, 2. And now we just have to make sure that the length of this long line is 4 multiplied by 2. So let's have a quick look. 1, 2, 3, 4, 5, 6, 7, 8, 9. No, it is not absolutely correct just yet. So let's just edit that one to make it the size we need. Just making that small there. Alrighty, so let's have a quick look and just see where we're at with this one. We can see there that we've enlarged the length from 1 to 2, because it's multiplied by 2. And we can see we've multiplied our height, this long length, by 2 as well. So it was 4, and now on this side it is absolutely 8. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Final little snippet that we'll show you today, and then we'll get on to some questions, is enlarge this shape by SF, which is scale factor 1/2. So a fractional enlargement means that the shape is actually becoming smaller, and the dimensions that you're timing by will be multiplied by 1/2, or whatever fraction you are using. So when you're multiplying by 1/2, you always multiply the numerator first by the number, and then divide it by the denominator. So in this instance, we've got ourselves a star. We have to enlarge the star by scale factor 1/2. And I'm going to start with the distance between this point and this point, because it's on a nice long line. So I can use that as my guide. So I can see that there's 1 centimeter, 2 centimeters, 3 centimeters, 4, 5 centimeters, 6 centimeters, 7 centimeters, 8 centimeters, 9 centimeters, 10, and 11 centimeters. So 11 times 1 is 11. So that's my top of the fraction, my numerator. And then I'm going to divide 11 by 2 to understand how I can change that to make it smaller. So 11 divided by 2 is 5.5. So I'm going to take my shape here and reduce it down. So the distance between the star is 5.5 squares. So let's just have a go, see if I can absolutely manipulate that round. All right, so I've managed to get the number of squares between the 2 points to 1 to 2, 3 to 4 to 5.5, which is 11 multiplied by 1/2. So let's make sure that the rest of this enlargement has gone smoothly as well. Always got to check every part of your answer to make sure it's absolutely spot on. So let's have a look at this one here. We've got between this point and this point, 1, 2, 3, 4, 5, 6 centimeters. So 1, 2, 3, 4, 5, 6, or 7. My apologies. 7 centimeters. Always recheck. Make sure you're absolutely spot on. So 7 centimeters here, which means 7 times 1 is 7, divided by 2 is 3.5. So I'm hoping that this is 3.5. 1, 2, 3. Oh, it's pretty good. So 3.5 there as well. So I'm going to say that this is a great and accurate enlargement by scale factor 1/2. Let's get on to some questions. Okay, so questions wise, I'd like you to have a look at each of the shapes. For question 1, with this shape just here, I'd like you to tell me, when we enlarge this shape by scale factor 3, can you tell me the new height and the new width, please? Alrighty, same deal for question number 2. This circle, you can see currently the diameter is 1, 2, 3, 4. And I would like you to enlarge this circle by scale factor 3. So can you tell me the new diameter for question number 2? Number 3, and remember you can pause this and go back, so don't feel like you're rushing through it if you need some more time. Question number 3, we're looking at this guy right here. It says enlarge the shape by SF2, please. Can you tell me the new width and the new height of this? And then to make it a little bit easier, I will just edit this a little bit so it's perfectly on the centimeter squares. And this one just down here is a little bit trickier. I'd like you to actually draw the new shape by enlarging the shape by scale factor 1/2. If you can't draw it, just tell me in question 4's answers the new height and the width. But what I'd absolutely love you to do is draw it, take a picture, and upload it. Alrighty, those are the 4 questions. If you're struggling, you can pause and go back. Otherwise, looking forward to your answers and getting you onto the task when you're in class. Thanks, team.